Okay, so here is a different way to generate a sequence, and we call this a recursively defined sequence. And the way a recursive sequence works is it doesn't give you a formula that you could plug in an n value and figure out what the 10th term or the 100th term is necessarily. But what it does is it gives you sort of a formula, a recipe for how to get from one term to the next. So here's an example. I have a sub n plus 1 equals the square root of 6 plus a sub n. A sub n would be whatever term in the sequence, my nth term, and a sub n plus 1 would be the next term. Now I also have to give a first term in the sequence, so I have a starting point. So if I start with a sub 1 being root 6, then the way this works is a sub 2, which is the term after a sub 1, would be the square root of 6 plus a sub 1. I would put the previous term right in there, and I get the square root of 6 plus root 6, which if you work out it on a calculator is about 2.91. If I want to know what a sub 3 is, then I'm going to take, that's the next term after a sub 2, so I'm going to put in a sub 2. I'm going to put in this answer in right here, the square root of 6 plus a sub 2, so that went in right there. And you get the square root of 6 plus root 6 plus root 6. If you work that out on a calculator, you get about 2.98. One more term. If I want to find out what a sub 4 is, as you've seen, I'm basically going to take a sub 3, the term before that, and put that in right here, right? I'm going to put that in for a sub 3. And you start to see this is going to be like an infinite square root of 6 plus root 6 plus root 6 plus root 6. Okay, carried out to the fourth term, that comes out to be 2.99. Now, as we've seen with sequences, one of the things we're interested in is whether the sequence converges or diverges, whether the terms in the sequence appear to approach a number, or do they go to infinity? Do they oscillate between two different numbers? So that's what we want to know. Now, if you just look at the last two answers we got 2.98 for a sub 3 and 2.99 for a sub 4. So if we had to make a guess, it certainly looks like the terms are getting closer to 3, right, as we move along here. But how do we know that for sure? How do we know, 2.98, 2.99, maybe the next term is 7 or something like that, something different? Well, when the sequence converges, what we'll find with the recursive sequence is the next term will be very, very close to the previous term, okay? So in reality, if you were to work out a sub 5, you would probably get 2.99. If you looked at your third decimal place, they'd probably be a little bit different. But what ends up happening is if the sequence converges, you'll start to see these numbers get close together, and they'll start to settle down on a set number here. So how do we know when it's converging? Is when the next term comes out to be essentially the same as the previous term. So when a sub n plus 1 equals a sub n, then we know that we've probably found the point where the sequence converges. And so the trick to finding that is we're going to call both of those, I like to use L. We're going to replace in our formula for our sequence, we're going to replace a sub n plus 1 and a sub n both with L. So here's what that looks like. Okay, so there's our sequence. When it converges, both a sub n and a sub n plus 1 are both going to have the same value. We'll call them L. We'll do the algebra. We'll square both sides, move everybody over, do some factoring, and we get two possible values for our limit. We get either 3, which is what we were expecting, and we get -2. So the way this works in the world of recursive sequences, the two possibilities for my limit, those are called fixed points. Okay, they're fixed points. And what happens is fixed points give you candidates for what the sequence converges to, if it converges. So the way you would tell then is we already collected some data. We found out by the fourth term we got 2.99. It certainly leads us to believe that this sequence converges to 3. And we never got any negative numbers out of that anyhow, right? So that actually is not going to be what our sequence converges to. So it's a combination of two things. The fact that 3 was one of our fixed points, and that when we worked out some of the values, we saw that the numbers were getting close to 3. So then we can conclude that this sequence converges to 3. Okay. Here's another one. So I have a sequence that starts 2, and then 2 plus 1 over 2, 2 plus 1 over 2 plus 1 over 2, 2 plus 1 over 2 plus 1 over 2 plus 1 over 2. So this is an infinite sequence that's generating, this is called a continued fraction. And now this one we weren't given a formula for, so we have to come up with our own formula. So 2 is our first term in the sequence. We'll call that a sub 1. And remember how a recursive sequence works is you want to come up with a formula for how do you get to the next term based on the previous term. Well, the next term was 2 plus 1 over 2. It was 1 over this number here. So it's a sub 2 is 2 plus 1 over a sub 1. If you think about it, a sub 3 was 2 plus 1 over a sub 2. In other words, you just did 2 plus 1 over, and you just took this value and put it in right there, right? Same thing for a sub 4. That's 2 plus 1 over this, okay, this whole thing. So our formula for this recursive sequence is a sub n plus 1 equals 2 plus 1 over a sub n. And of course, we know our starting value was 2. Let's find the fixed points and see what this converges to. I have L equals 2 plus 1 over L. I'm calling both a sub n plus 1 and a sub n equal to L. Multiply both sides by L. Move everybody over. Unfortunately, this one doesn't factor. So I have to use the quadratic formula, and I get two possible values from my quadratic formula. I get 2 plus root 8 over 2 and 2 minus root 8 over 2. 2 minus root 8 over 2 would be a negative value, which means this thing has to converge to the positive value, which was, okay, if you split that up, that's the same thing as 1 plus root 2. Okay, 1 minus root 2 is negative, so that can't be the limit. I'm going to throw in one more example just to give you a little more insight into how fixed points work. Check out this one. Say I have, so this will be number 3. A sub n plus 1 equals 4 over a sub n. And let's say I start with a sub 1 equaling 1, okay? So we might let's just go straight and find our fixed points here. So we know we did that by setting these both equal to L, a sub n and a sub n plus 1 and a sub n. So I'll have L equals 4 over L. That gives me L squared equals 4, which gives you two possible fixed points of plus or minus 2. Now here's the thing with fixed points though. They only give you candidates for what this sequence, if it converges, it would have to converge to either 2 or negative 2. But I say if it converges. So what you have to do is you have to collect some data to figure out, is it going to converge to one of those numbers? So let's try it. If a sub 1 is 1, to find a sub 2, I'm just going to put that in for a sub n. So I'm going to get 4 over 1. A sub 3, I would put the 4 right back in there. I get 4 over 4, which is 1. A sub 4, put the 1 back in. I get 4 over 1, which is 4. And hopefully you can see what's happening here. I'm sorry. 4 over 4, there we go, which gives me 1. Notice that these terms are just going to oscillate between 4, 1, 4, 1, which means even though my fixed points were plus or minus 2, this sequence is not going to converge to either of those numbers. And in fact, it's not going to converge at all, right? It's clear here that these terms are going to oscillate. Terms oscillate. Therefore, this is going to diverge, right? So maybe just one note on this. Fixed points are only candidates for the limit of the sequence if, I'm going to underline if, the sequence even converges, right? In this case, the sequence didn't converge. If the sequence converges. Okay. Now, all right, maybe one more example here. Let's say I had that same sequence, a sub n plus 1 equals 4 over a sub n, but this time I started with my first value being 2. Okay. Well, we already know our possible fixed points are plus or minus 2. Now look what happens here. What's a sub 2? You would plug that in. 4 over 2 gives me 2. A sub 3, 4 over 2 gives me 2. A sub 4 is going to be 2, and so forth. So clearly here, every single term is 2, which means we know that the sequence converges, right? To 2. Now, how would we know it converges to 2? Well, 2 was one of our fixed points, right? And maybe this gives a little more meaning to that term fixed points, right? What a fixed point means, the reason we give it that name is if that's your initial value, if you plug in one of your fixed points as a starting value, the terms you get are fixed. They're never going to change, right? All you're ever going to get is 2 if you start with the fixed point of 2. Okay, so recursive sequences we won't use too much. Most of them are the more of the explicit kind of sequences in this section, but they are worth studying. We will see some examples of those. All right.